Dear children, let us study about the strength of an acid. What are the factors affecting acid strength? Acid strength depends on two factors. First one, if the let the acid be of the formula Ha. Acids are substances which can produce hydrogen atom as proton. So it contains hydrogen atom. It can be any group. So Ha is the form of an acid. The strength of this acid depends upon strength of Ha bond. Strength of the acid depends on the second factor, polarity of this bond, Ha bond. In the case of acids formed by elements of one group in the periodic table, strength of Ha bond is the determining factor. For acids formed by elements which belong to a period in the periodic table, polarity of Ha bond is the determining factor. So let us take strength of Ha bond. How strength of the Ha bond influence acid strength? If Ha bond is strong, if Ha bond is strong, the bond strong means it is difficult to break. Difficult to break the bond, right? If the bond is difficult to break, the formation of hydrogen ion will be difficult, right? Difficult to, that is difficult to produce H plus ion. If it is difficult to produce H plus ion, it is a weak acid. That results in weak acid. Acid strength will be less. That means Ha bond is strong, the acid is weak. On the other hand, if the bond between hydrogen and A is weak, if the bond is weak, easy to break. Easy to break the bond, right? If the bond is easily broken, what happens? Easy to produce H plus ion from it. Easy to produce H plus ion means it's a strong acid, right? So if the Ha bond is weak, if Ha bond weak, strong acid. If Ha bond is strong, weak acid. So how acid strength and bond strength related? Acid strength inversely proportional to bond strength. Bond strength of Ha bond. When bond strength increases, acid strength decreases. Clear? So this is the determining factor, that is bond strength is the determining factor for comparing acid strength of compounds formed by elements of a group. Let us take an example. Group 17 elements. The acids of group 17 elements, hydrides of group 17, HF, HCl, HBr, HI. These are the acids formed by group 17 halogens, fluorine, chlorine, bromine, iodine, belongs to the same group. Now down this group, size of the halogens increases. Down the group, size of the halogen increases from fluorine to iodine. Electronegativity of the halogen down the group decreases. Fluorine is most electronegative, iodine is least electronegative. So when the size increases, electronegativity decreases, what happens to the bond strength? HX bond strength down the group decreases. If HX bond strength down the group decreases, what about the acid strength? Acid strength down the group increases. We know bond strength and acid strength inversely proportional, right? So if you arrange the compounds in the order of HF acid strength, HF, HCl, HBr, HI, the acid strength will be down the group it increases, means strongest acid will be HA. HA is stronger than HBr. HBr is stronger acid than HCl. HF is the weakest acid. HF is weakest acid, HI is strongest acid. Why? Because fluorine small size. Fluorine small size, most electronegative, strong bond. Strong bond, that is HF bond is strongest. So it is difficult to break, difficult to produce H plus ion, weak acid. Now in the case of iodine, iodine is large, less electronegative, electronegativity less. So HI bond is weak, weakest. If the bond is weak, acid strength high. Very easy to break, easy to donate H plus ion. So this is the strongest acid. Clear? So this compound's acid strength depends on strength of the HA bond. When strength of the HA bond increases, acid strength decreases. Inversely proportional. Now when we come into compounds which are formed by elements of same period, then the acid strength depends on the second factor, that is polarity. Polarity of HA bond. When the HA bond polarity increases, when the bond becomes more polar, there will be more charge separation, easy to break the bond, acid strength increases. That means acid strength directly proportional to polarity. When the bond becomes more polar, there will be more charge separation, easy to break the bond, hence easy to produce H plus ion, then acid strength increases. This is the determining factor in the case of compounds of elements which belong to the same period. For example, methane. We know carbon, nitrogen, oxygen, fluorine. These elements belongs to the second period. Now the hydrides of these compounds, let us write CH4, NH3, H2O, HF. These are hydrides of second period elements. Carbon, nitrogen, oxygen and fluorine belongs to the same period. So when we compare the polarity of these bond, carbon hydrogen bond, nitrogen hydrogen bond, oxygen hydrogen bond, fluorine hydrogen bond, here when we see electronegativity from carbon to fluorine increases. Electronegativity increases, this order. Electronegativity increases means that there would be large difference. The difference in the electronegativity of the bond atom increases towards right side, which means the polarity increases. Bond polarity increases towards right side. Towards right side, bond polarity increases. So the bond polarity will be minimum in the case of CH, maximum for FH bond. Means FH bond is most polar. CH bond is less polar, least polar among these. Clear? So here acid strength and polarity, how are they related? Directly proportional. So what is the order of acid strength? Acid strength also follow the same order. Most polar bond is HF. So this is the most acidic. Then H2O, then ammonia, then methane. So acid strength increases from methane to HF because polarity of the bond increases. Because electronegativity increases from carbon to fluorine. As electronegativity increases, bond polarity increases, acid strength also increases. So acid strength also increases towards right side. Okay.